So, today we're going to talk about something pretty radical, a complete first principles redesign of our entire electricity system. It's a new blueprint that basically asks a really simple question. What if we actually built our energy market for the 21st century, instead of constantly trying to patch up a system that was designed for the 19th? Let's dig into it.
This quote right here really sets the stage, doesn't it? It's basically saying that for the last 30 years or so, our energy policy has just been a series of band-aids. We've been treating the symptoms while completely ignoring the disease. So this isn't about a minor tweak. It's about a deep, systemic failure.
And yeah, this brings up the big question, right? The one I'm sure you've asked yourself. We keep hearing we're in this amazing green revolution, that renewable energy is getting cheaper and cheaper. So why aren't our bills getting cheaper too? To figure that out, we've got to look under the hood of the system we have right now.
All right, so let's get into the diagnosis. Why is the market we have today so, well, broken? The answer is kind of surprising. It isn't really one market at all.
I mean, just look at this. It's this collection of separate, fragmented markets all just layered on top of each other over the years. You've got the wholesale market, the capacity market that pays power plants just to be on standby, and a whole bunch of others. Each one was created to solve one specific problem, and the result is this tangled, complicated web of systems.
And here's the really important thing to understand. This complexity isn't a feature, it's a bug. This whole patchwork creates a ton of bureaucracy and inefficiency, mainly because these different markets are often sending conflicting signals. You end up with a system of systems that just don't talk to each other properly.
Okay, but the problem? It actually goes way deeper than just a messy structure. It's about the fundamental economic rulebook we're using to run the entire grid.
This slide just nails the core issue. See, back in the 90s, when our markets were designed, we literally copy-pasted the rules from 19th century commodity markets, like for trading wheat or oil. But here's the deal. Electricity is nothing like wheat. You can't just store it in a giant silo. The grid is a real-time physical system that has to be perfectly balanced every single second. It's run by the laws of physics, not just simple supply and demand.
And the key rule we borrowed is this thing called marginal pricing. And it's kind of wild how it works. At any given moment, the price for all electricity is set by the single most expensive power plant we need to turn on to meet demand. So if we need to fire up a pricey gas plant just to keep the lights on, guess what? Everyone gets paid that high gas price, even the wind farm where the fuel was completely free.
Now, in a world that was mostly fossil fuels, this system kinda, sorta made sense. But now, in a world with more and more renewables that have zero fuel cost, the whole logic just shatters. Marginal pricing was never, ever designed for an energy source whose cost to run is zero. It's sending all the wrong signals for what we should build and how we should run the grid.
All right, so we've established the problem, a fragmented system running on like an ancient operating system. So now, what's the fix? Well, let's get into the proposed solution, a complete redesign from the ground up.
The big idea here is to just stop. Stop patching the old system. Instead, let's build a new one based on first principles. The core concept is to stop treating the grid like it's a market for wheat and start treating it for what it actually is here in the 21st century, a digital cyber-physical system. It's a control problem, not just an economic one.
And this whole new design, it really comes down to three main pillars. Number one, putting fairness first, right into the rules. Two, moving to what's called an event-driven operation that works in real time. And three, using digital regulation to make the whole thing transparent and automatic. So, what on earth does event-driven actually mean? Well, think about it this way. Our current system is batch-based. It settles the market in these clunky half-hour or even one-hour chunks. An event-driven system, on the other hand, clears continuously in real time. So when a cloud passes over a solar farm or a big gust of wind hits a turbine, the market can respond instantly. And that speed, that's what allows it to finally integrate and value millions of small things, like your electric car or your smart thermostat.
So how is this real-time magic even possible? Well, it all comes down to a really powerful piece of tech at the heart of the whole system.
It's called an automatic market maker, or AMM. Now, don't let the name scare you. The best way to think of it is as a digital scarcity controller. It's an algorithm, right? And its whole job is to constantly watch the physical state of the grid, the voltages, the congestion, all of it, and instantly translate that physical reality into a price.
What it does is create this beautiful, simple feedback loop. The system senses the grid's condition, the AMM sets a price, and then automated devices all over the grid act on that price signal. It's a control system that uses price as its language to keep everything stable and efficient.
And this isn't just one giant all-seeing computer running the show. The architecture is holarchic. Yeah, it's a fancy word, but think of it like those Russian nesting dolls. Each part of the system is also a complete system in itself. So you have prices being set at every single level, from one EV charger to a local neighborhood, all the way up to the national grid. Everything is connected in one coherent framework, making sure that a tiny action at the edge of the grid supports the stability of the entire thing.
Okay, so we've talked about a lot of tech here. What does it all mean for us? For the future? Well, it brings us right back to those big goals. A system that's not just efficient, but also fair and has zero waste.
Let's talk about the zero waste idea first. You know how sometimes we hear that wind farms are getting paid to shut down? It's crazy, right? That's because the grid just can't handle all the power. A zero waste system is designed from the start to use every last drop of clean energy, flexibility, or storage. Nothing useful ever goes to waste.
And then there's fairness. How do you actually bake that into the system? Well, this new design uses a really cool concept from game theory called the Shapley value. Now, stick with me here. The easiest way to get it is to think about splitting a dinner bill with friends based on exactly what each person contributed to the meal. It's a mathematical way to precisely calculate and reward every single generator, from a huge offshore wind farm down to a battery in someone's garage, based on their actual contribution to keeping the lights on. No more, no less.
So let's bring it all home. What's the real-world impact of all this? Well, by finally running on the right rules, the system can deliver lower costs, a way more stable and resilient grid, and a much faster, cheaper path to decarbonization. It fixes the broken incentives and makes sure that everyone who helps the grid, no matter how big or small, gets rewarded fairly. This is the payoff. A system that works with physics, not against it, to create that cleaner, cheaper, more reliable energy future we're all hoping for.
And that really brings us to the final thought, doesn't it? The technology and the theory we've talked about here, they exist. A fair, zero-waste, digitally native grid is not science fiction. So if we actually can redesign our system to be this much better, the only question left is, what are we waiting for?